All right, let's go ahead and get started. Hey everybody, and welcome to this webinar. My name is Dave Hedeman. I am the application specialist for the steel segment here at Trimble. And today we're going to be taking a look at using Tekla Structures for detailing and fabricating your miscellaneous steel. So before we get started, I do want to point out that everyone who's joined the webinar is in listen-only mode. So if you do have any questions as we go through this, go ahead and type those into the questions pane or the chat window that you see on your GoToWebinar dialog box. What we'll do is at the end of the presentation portion, we're going to go through those questions. We're going to answer some of them live for as much time as we can. And then afterwards, if we don't answer your question, we're going to follow up with you, through email to make sure that you get all those questions answered. So that's where you want to enter them if you have them. So we do have probably a diverse audience joining us today. We're going to have Tekla Structures users who are already detailing a miscellaneous steel with Tekla. They're here to find out what kind of new tools we have and some workflows and things like that. And we're going to have some good stuff for you guys today. We're probably going to have some people who already use Tekla for your structural work, but you're not using it for miscellaneous yet. And today you'll see that we've got a lot of tools available that are really going to be great for that side of your business so that you can start using Tekla for your miscellaneous. And then finally, there's going to be some people who are still using 2D CAD to do all their detailing. They're considering moving up to a 3D package and they're curious about Tekla. And what you'll see today is how powerful our tools are and how they can really change the game for your steel business. So we're going to be looking at some basics, stairs and rails, the bread and butter type work that most people do with miscellaneous steel. We're going to be creating drawings of them, making changes in the model, see how that affects the drawings. We're going to be getting fabrication data out. We're going to be doing bent, curved material, plates, spiral, stringers, channels, tubes, things like that. We're also going to be making custom objects and custom components or custom tools. And I do also want to say, make sure that you guys check out our YouTube page. If you search for Tekla Structures, you'll find that there are a couple of playlists that you can sign up for. One of them being Monday Minutes, that's our recent steel development. The other being Tips and Tricks, which is pretty much what its name implies. So there's a lot of these things that we come out with these videos, and we show these videos or we create these videos a lot more often than we do these webinars. So definitely check that out. I'm going to be showing a lot of that stuff here today, but kind of pulling it together into some workflows and also showing some new tools. All right, so let's jump right into a Tekla model. So I wanted to start with this because it's kind of a great example of mild to wild, as the saying goes. If I zoom in on this stair that we see on the right, this is going to be, again, that kind of bread and butter work that most people are doing. Concrete filled pans, going up to landings, maybe you have a switchback, maybe it's turning 90 degrees like this one is. We've got some picket rails, we've got some wall rails, and this type of stair, if this is the type of work you do day in and day out, our automated tools are going to blow you away as far as how fast you'll be able to knock out this type of stair. So we've got stair tools, we've got railing tools, all of this stuff can be very, very highly automated. Now, that being said, if you get into projects that are a little more architectural, that are a little bit more unique, you can absolutely do those types of projects in Tekla Structures as well. This is a customer model that they sent to us as part of a model competition, and I love this thing because it's just a great example of how custom you can get with the stuff that you're building in the model space. We have some triple stringer stairs with plate side panels. We've got glass, glass rail panels with button brackets and button brackets for our actual handrail or grab rail. I mean, everything about this is custom. And even though you have to draw it or model it the same way that you might have to draw it in CAD, all of the benefits of using Tekla Structure then pile on top of that. Center of gravity, automatic BOMs, CNC information automatically generated from the model, smart intelligent drawings where your dimensioning is automated. So there's a lot of benefits even when you have to just draw it yourself. So never think when you look at a project like, man, I don't know if Tekla is right for this. Absolutely, Tekla will make that job go easier and smoother. Definitely recommend using our tools. So let's get into actually building something here so we can see how quick and easy you can make a stair. So in this corner of the model here, I've got a little grid created and I've already got my elevations laid out. What I'm working off of here is an actual design drawing that somebody sent me. This is an architectural of a stair. This is the kind of thing that you guys probably see a lot of. So this sample is of a two-floor with landings, switchback stair, concrete filled pans. So again, bread and butter type work. So what we're going to do In the Tekla models, we're going to build that. I already have some of the stuff laid out, like I said, the grid. Something else I'm also going to turn on here is my landings. Now, I cheated a little bit. I have these pre-built for me in order to save time because I want to focus on the stair and railing tools. Making something like a landing is very easy, though. You load up the beam tool, you choose a channel, a plate, an angle, whatever that happens to be. You pick 2 points. You create a beam. So you can just draw those out, and, like you're drawing out something in CAD. Okay, so I don't want to focus a lot on that. That's why I already have them in here. Now, normally what I would do to create a stair is I would take my calculator, I would switch it into stair function, and then I would just do my math, figure out where my nosing points are. Well, in Tekla, we do need to know those nosing points, but rather than me doing the math and trying to figure that out, we have a series of tools that will help me do that. These two new tools called Stair Layout and Stair Layout with Landing will do the math for me and create construction lines of my nosing lines for me to pick on. So they just make that process a lot easier. So if I double click on Stair Layout with Landing, what I want to do is just fill in my information. So based off of that design, I know that my floor level is at 10 foot 11 3/8. I know that my maximum landing is at 6 feet. I know that my landing width is at 4 foot 6. And I'm going to set the distance between my nosing to nosing at 0. So you can adjust that as need be. But what I'll do is pick 2 points, and it creates those construction lines I was talking about at the proper pitch for me to create my Tekla stairs. So I do have one more level. I'm just going to adjust the height floor to floor. Again, I just have these written down because I pulled them off that design drawing. And we can see how it's creating those construction lines in my model space. Now, something else that I like to do is maybe use my designs in a better way. So rather than flipping to a sheet of paper or flipping to a PDF and looking back at the Tekla model, going back and forth, we can actually utilize that design drawing right here in Tekla model space. So if I go ahead and create a view, here I've got view properties called elevation on stair A. I'm going to use the pick 2 points to literally pick 2 points along the center of that stair, and now I have a view cut at that stair. In this view, we can see there's my landings, there's my construction lines, but I can then import the PDF document of that design drawing. If we know the scale, we can set the scale. If you don't know the scale, we have a tool that can help you bring that in at the proper scale. Right now I've brought it in at a simple 24 by 36 inch sheet of paper, so that's not going to do me a lot of good like that. On our warehouse there's a tool called the reference model scale. What this does is it allows me to simply pick on the drawing that I've inserted, and then I can pick on 2 points of a known dimension. In this case I'm picking floor to floor. So that's 10 foot 11 3/8, and in this window it asks me, okay, how far are those 2 points actually supposed to be apart? I say 10 foot 11 3/8, I click OK, and then that tool will scale it up for me to the full size. Now that it's inserted into the model, it's just like any other model object. I can move it, I can rotate it, I can copy it. We can have multiple PDFs in here. But this is just great, especially when I'm bringing in an architectural drawing, to make sure that I'm matching the design intent. They'll put some dimensions in on the architecturals that maybe don't work out when you're actually trying to fabricate it, but we can at least make sure that we're following the intent here. And I think based on where my construction lines are falling, you can see they're following the nosing lines, that we are definitely doing that. We're just doing a little bit better math of laying out our stairs where they need to be. So this is just a great way to match up. You can snap to it. You can work off of this. So it's a really great way to help guide you through the Tekla model. I'm going to go ahead and hide that just for clarity in this, but all I can do, or all I need to do, is toggle it off. I can toggle it on at a later date if I want to double check my work as I'm going, but it is permanently kept in that reference models list. So when it comes time to actually start creating a stair, I can go here to my component catalog and I can drill down to the proper section: steel detailing, miscellaneous detailing, stairs. Or, especially for those who haven't used Tekla before, we can simply do a search. If I type in the word stair, it brings up a list of all of the commands and all of the tools that have anything to do with stairs. So I'm going to be using this Z-pan down here, and I'm just going to put in a baseline stair. I'm going to pick 2 points. I'm going to middle mouse click, and you can see how it's created a simple stair for me. That's how fast you can create a stair layout. Okay, so if you're just trying to do a quick mock-up, you're trying to get an idea of a piece count or something like that, pick 2 points, boom, you're ready to go. Now I'm going to make some adjustments to this stair because I have to fit it inside this tower. So I'm going to make it 4 feet wide. I'm going to change the the dog leg at the top to simply extend straight because I'm going to use a different type of connection up there. I'm going to go to the stair setup and let's see what we want to do here. We can adjust how it's being supported. Are we using angle brackets? Are we using bent plate? Are we just welding the pans right to the stringer? Do we want this to all be welded together? Well, maybe I do, so I'm going to go ahead and set this up to be shop welded rather than field welded, so you control, is this something that's going to be assembled in the shop, or is this something that has to be fit into some existing door openings where we're going to assemble it on site? We can choose our stringer size. This can be regular channels, miscellaneous channels. This can be plate, HSS. Any shape in the shape catalog can be used here. For the pan at the top, I'm going to go to the Z-Pan tab and make some adjustments. I need this to only come back, say, 3 inches and then be 3 inches deep because of the concrete thickness out of my landing. And then the final thing I might do is offset this. So rather than trying to use a move command or something like that, back on the stair setup tab, I'm going to tell it offset to the right, and I want that to be offset by an additional 3 inches. So making room for the next stair to come in. So now that that setting has been applied, I can use those same settings to create the rest of my stair. Now I might have to make some adjustments on the different levels, but this is just a really fast way for me to come up picking points, knocking out those upper levels of stair stringers or stair runs. So now that I have those in, I might start making some adjustments to these, start doing the quote unquote the detailing, right? So for the base of this stair, we have specific base details. So I'm just going to pick those stringers, tell them where my guideline is or where my nosing line is. And when I do that, it adds the cuts, puts in holes for expansion anchors or epoxy anchors or however we're going to attach that down to the concrete. Up here at the top side, I could use any regular old steel connection, but we do have specific connections that will just cut a notch and put a closure plate on it. There's another one here that will actually cap the top of it rather than running that up to a point. Whatever you prefer, whatever the designs are calling for, you can use any of those connections here. Now for the next stair, obviously that's a little bit high because on the original settings, it was meant to come down to a concrete finished floor. That's what this red box is indicating at the bottom of the stair. So all I'm going to do is change the setting here to instead create a step at that location. And then I'm going to adjust my pan to come down and rest on this channel. So what I'm going to do is measure. Let's find out what that distance actually is. So it looks like that's 9 15/16. I'm going to leave a little bit of clearance there, so I'm going to adjust this bottom pan, tell it to come down 9 13/16, and then maybe put a little, let's say 2-inch return on that. Maybe I'll give it an extra inch. We'll make that a 3-inch return to sit on top of that channel. Okay. Last thing I'll do for this bottom section is put on my base details, just connecting that stringer to the header beam, and we're pretty much good to go with that one. Now at the top side, while I'm looking at this, I'll go ahead and I'll attach you. But the top side of this particular stair, let me spin this guy around again. I always like rotating around what I'm working on. That way I'm getting a real clear idea of exactly how this is fitting up. This one, I'm going to change the top. I'm going to tell this to extend to meet up with the face of that stringer, and we'll zero that value out. So now I have a little dog leg at the top rather than a squared off or an extended stringer. So again, you have options for how you want to put this together. In this case, I'm also going to extend out. We'll come out a foot. That should be enough that it's sitting on top of that channel. And then anything else we want to do in there, like a deck plate or any other type of plate work, could finish that off as far as our concrete support goes. Okay, one more adjustment I'll make to this other stair. Let's do a measurement here. That comes out to 9 3/4, and we will, let's see here, go to my pan. Again, I'll come back just a little bit, make it a little bit short. And there we go. 3 inches is a little much. Let's make that 2 inches. There we go. So we can just adjust and tweak as we work up this. But the basic stairs, as you saw, were very, very fast to put in. Let me finish off just a couple more here. I want to try to complete this as much as I can. Okay. And you know what? This stair and this stair are very similar. So what I'll do is I'll kind of borrow the properties of that. We'll extend the bottom down. Looks like the dimension even worked out for the pan itself. and we will finish off the stringer sides like we did before. So, always be thinking about that. Well, if there's something similar, what can I use so I don't have to redo that work, or retype in all those values. So we'll apply that to that stringer, we'll apply that to that stringer, and I don't have anything to connect to up at the top. I never put a landing up there, but hopefully you get the idea of what we've been doing so far. Okay. So the next thing I might want to do is create some handrail. Now, a handrail can be put in very quickly, or it can be put in using individual tools. The fastest way to put one in is using this S86. We do have some presets. I'll put in one of the default presets just so you can see what it looks like. You pick 2 points. Where does it start? Where does it end? And then it can create a rail. Rail, kick plate, grab rail if you want it. Okay, so that's one of the fastest ways to get those in. I like to have a little bit more control though. So what I'm going to do first is put in some posts. So I just took that out. Again, I'm going to pick 2 points here. Where does it start? Where does it end? And then I'm sitting on the stringer, and there's my posts. Any shape that's in the shape catalog can be used here. And then we can adjust things like the spacing. Maybe I want that to be maximum of 4 feet. It looks like I'm still within that. Maybe I want to do maximum of 3 feet. You can see how it adds additional posts. I'll stick back with the 4 feet. We'll make this a little bit shorter, 3'8". And then, any other adjustments we might need to make, we can do through this dialog box. Then we can use those same settings and just reapply them on the next levels of stair. So I'm going to say, where do I want this to start? Where do I want this to end? What am I sitting on? Let me turn this around. Okay, and then we'll go to the next run. Where do I start? Oop. Rotate this around. Where do I end? What am I sitting on? And then one more run just for fun. Where do I start? Where do I end? And what am I sitting on? Yes, I actually do that in my head as I'm building stairs. Okay, so once I have those posts in, well, now I can start connecting them together with rail. And the basic railing tool is going to create a pipe rail. So when I apply that, we get the same type of pipe rail we saw a minute ago. But there are a lot of default settings in here, especially in the US Imperial environment. If you want to create a different type of railing, load up one of our presets as a starting point. So maybe I'll load picket rails here. So I'll load picket rails with no returns. I'll hit modify, and now I get some picket rails put in there. Usually the best thing to do is go ahead and keep using that for all the rest of the stairs going up. So I'll simply apply this to the next run of posts. I'll try not to rotate too much in here. Pick the next run of posts. Pick the next run of posts. Now, ideally, what I would do is save those 2 settings away, the post location or the post spacing and height, and the railing that I want, and then use them together inside of this tool. I'm just kind of being lazy today and putting them in separately. Now, if I wanted to create a grab rail, the grab rail goes in the same tool. So I'm going to load another preset here called grab rail left side. I'm going to pick the post working my way up and create that grab rail with brackets. Now, I am going to make one adjustment to it here. I'm going to adjust this so that it extends an additional couple of inches because I need to make a return. So I'll say, yep, go ahead and extend an additional 3 inches, and that should be pretty much good. Just for fun, I'll add one more. I don't want to spend too much time on this because there's a lot of other stuff I want to show you, but I'll at least do one more run. So we'll add the grab rail, except this time I'm going to adjust the bottom to only extend 3 inches instead of a foot. Okay, so now that I have those in, the final type of detail work I might need to do here is like adding a return. And I want to switch to a manual mode here just to show you how, there are times that the automatic tools or the automated tools will do a lot, but sometimes you just need to switch to a manual mode and start drawing stuff. So I'm going to come in here, say, yeah, I want you to come down 18 inches. I'm going to try to pick the right points even though I'm moving quickly. Let me change some of my snaps here. So we'll come back a foot, and we'll come back and snap to the center of the main post. Now, something I also teach people is to model how you fabricate. So if you're going to be going out and buying or ordering elbows from an outside company and using those, use our elbow tools. That way you're going to get a separate line item in your BOM, you're going to get a separate object showing up here in the model, in your drawings and everything else. If you're going to be mitering parts together, then you want to use the miter tool and miter your parts in the model. So model how you plan on fabricating. And then if you plan on making this out of a continuous pipe that you're bending in your shop, well then use our tool called polybeam like I'm doing right now, And this is basically playing connect the dots. You just pick a bunch of points, you middle mouse click, and you can get whatever shape you like. Each of these corners can be double clicked on, and that will open up a properties pane where you can say, yep, let's go ahead and radius that 6 inches, let's radius that by 6 inches, let's radius this by 3. So you can control those bends independently at each corner. Okay. For the corners here, I'm also going to miter the top rail. A lot of people are using different types of connectors, or some people are mitering. So we do leave this open to you guys to choose whatever connection type you like. I'm going to go ahead and put in a miter just because it's simple, and it gives a nice clean look in my opinion. So for the actual return, we do have some tools that will build that. Personal preference, though, again, is to just go ahead and click a part, or a beam part to connect those two. I am going to add a split command, which is where I'm going to add a splice, or where I would have a splice. We do have a tool that will also do that, put in like a solid insert, or a smaller pipe insert if you desire. And then I'll just miter the corners of these guys again for simplicity's sake. Okay, so once I have all that in, it's always a good idea to just check, are we all welded together that we expect it to be? And in that case, the answer is yes. Is the lower stair all welded together the way I expect it to be? And again, the answer is yes. So at any time I can check that, pull up the weight of the total stair, the surface area of the total stair if you're trying to calculate how much paint is involved, center of gravity for the erector, all that information is always at your fingertips. Okay, so now that I've got these stairs in, maybe I want to start making some drawings. And I know I could keep going up, but again, for time and for content, I want to show you a lot more stuff. We're just going to stop there. If I want to create a drawing, one of the first things I need to do, especially if it's a plan drawing, is to open up a view at that location. So this is my elevation on stair A. It's that view that I created that was cut at the middle. And all you have to do is right-click in the background and say, make me a general arrangement drawing. Now we do have some default settings in here you can use. Everybody's going to customize these in the long run. So what I'm going to do is start with an elevation setting. I'll call this one, let me turn my caps on, elevation on stair A. I will change the scale. I happen to know that this isn't going to fit on a sheet well, so I'm just going to go ahead and adjust the scale right away. You can always adjust it after the fact, and then basically say, go ahead and make me a drawing. Now what Tekla does is it takes a window of that model space and it puts it on a sheet. So this window can be moved, it can be rescaled, it can be adjusted in a lot of different ways. Dimensions are created between the grid lines. You can see how piece marks are created. I can turn on and off hidden lines and things like that if I like. But one of the great things about Tekla drawings is if I want to add any dimensions, all I have to do is pick 2 points. And it is what it is. There's no faking, there's no fudging. We don't believe in this thing called dim scale, or why you would want to have to keep changing your dimension settings. All you do is just pick your points, and the dimensions are what they are. So if the model is right, your dimensions will be right. And as we always like to say, if it fits in the model, it'll fit in the field. Okay, so that's the basics of a plan drawing. Obviously, I would add more dimensions and things like that. But to make a shop drawing, slightly different process. So I do need to make sure for a shop drawing that my piece marks have been applied. So Tekla is going to keep track of similar parts versus dissimilar parts. So up here I'm going to run what we call a numbering. So I'm going to number the objects in the model. That quickly it's complete. And then I'm going to open up our master drawing catalog, which just contains all of the different drawing types that we have predefined for you. What you would typically do, let me go ahead and pin that guy so it doesn't go behind the screen. What you would do is you would highlight the thing in the model you want to make a drawing of, highlight the drawing setting you want to use, and then go about your day and make a drawing. What I'm going to do is instead run this guy called, it's called a rule set. It's got a little red star on it. These also used to be called drawing wizards back in the day. What you want to do is right click on that after highlighting those parts and say create drawings. And what it's going to do is look at the things that I have highlighted and then figure out what drawing setting I'm supposed to use. And that quickly it's done. So now if I go to my drawing list, we can see that there is a stair drawing and there is a handrail drawing created. If I open up the stair drawing, we can look at some of the basics that Tekla has created. Now I did try to squeeze it down on a sheet. Personally, I'm not a fan of that setting, so what I'll do is turn that off, basically saying don't try to squeeze that. If I need to move it over, I will. I'll move that I'll move that view over. And then we can update the dimensions if we need to. Bill materials are filled out automatically. By the way, we can switch to a black background if we want. We can also switch to like a black line work if you want to see kind of a print preview, if you will, of this. So there are different ways that you can view this sheet. I want to show you a tool, because while it does put in some basic dimensions, I want to show you this tool that will really help speed up your stair drawings. And just for clarity, I'm going to blow out all the original dimensions there. But in my components, I do have components on the drawing side as well. There's a tool that I've downloaded from our website called ZPan Dimensioning. So all you have to do is go to our Tekla warehouse and download it. If you double click on this guy, um, it gives you the option to create ZPan dimensions. So when I click on that button, I just follow the steps down here in the bottom left. I want to pick the first point on the nosing line, pick the stringer. I want to go up to the top and pick the last point on the nosing line and pick the stringer. And then the last thing it's prompting me to do is pick 2 points for a tread depth. Now you can see that it's gone and created all of the basic dimensions for me. Now, is it going to knock out 100%? Maybe not, but it's going to knock out a good 85-90% of the dimensioning that I'm going to need for this stair, including all my standard, rise and run type dimensions, running dimensions to the toes. So, this is just a great way to knock out the bulk of the dimensioning styles that you're going to want to put in on a typical stair. So, something else I wanted to show was a similar tool for handrail. So let me go back to my drawing list here. We'll open up the handrail drawing. And our handrail is kind of similar in that it's a pretty bare bones dimensioning style. And that's actually done on purpose because everybody likes to dimension their handrail differently. Everybody we ask, how do you like this done? We get a lot of different answers. So instead of trying to come up with a one size fits all, we created the handrail dimensioning extension. And what this guy does is it gives you a series of buttons of the different dimensioning styles that you might want to include. And all you do is pick a button, say, yep, this is a dimension that my shop likes to see. You click, and then Tekla will create that dimension for you. So this is just a neat little tool that really, again, 80-90% or more of the dimensions that you want to include. And these are just regular Tekla dimensions. So if I want to move them, if I want to adjust them, if I don't like how it came out and I want to delete it, that's fine. But it's going to knock out the bulk of those dimensions for me. On a drawing, if I want to do something like cut a quick section, for those who haven't used Tekla before, you can cut a section at any time in a drawing, and that will create a new window, including as much as you want to see. This kind of magenta box that I'm showing, as I drag that, you'll see that the section updates to include or exclude as much as I want. Dimensions can be added to this, and again, dim scale is not a thing. So if I come in here and I start putting some dimensions on, and I start adding things like piece marks to this little detail, maybe I start to realize like, wow, this is starting to get kind of crammed. This one isn't, but let's say that it was. We can come in and adjust the scale of this section cut, and the value of my dimensions does not change. So my font height stays the same, the value stays the same. Again, dim scale is not a thing for us. You simply just modify the view, and the dimensions will update or adapt, I guess is a great way to put it, to that scale. Now, one other thing I want to show about these drawings before I get into some other cool tools and stuff is changes. So, changes are a huge part of this business, and they are a big problem when it comes time to, hit your schedules, when it comes to cost, and changes are where Tekla is really going to save you a lot of time and money. Let's just say that we have this stair. Again, I'm working off architectural, so I'm working off a design intent to lay this out. Well, then we go out, we do some field measuring of the site, and we find out that the floor is actually an inch higher than it's supposed to be, or an inch lower than it's supposed to be. I'm sure that never happens to anybody, right? So what we can do is take this stair, let me grab it as a component, and I'll also grab all the associated stuff. So I'll grab the end connections at the bottom, I'll grab my posts, and we will highlight all of those. And let's go ahead and move those, like I said, an inch. I'll move those an inch up. Okay, something minor, kind of a typical change that you might see. So that little change is also going to affect the rest of the rails. So all I need to do to update those is give them a little bump, kind of let them know like, hey, something happened to you. You should probably adjust that extra inch. Hopefully you can see them shifting there when I do that. And now that I have that done, if I go back to my drawing of my stair and I try to open it, I can't. That's actually a deliberate protection put in place by the software. You cannot have a drawing that does not match the model. It just goes against the rules. So before I can open this drawing, I need to update my piece marks. Now, I already have a setting loaded up here, but you have different stages of a project. This one's just called After Creating Drawings. So I will go ahead and set that, run my numbering, and you can see how both drawings affected by that change get a flag saying Parts Modified. Now that I reopen that sheet, all of the dimensions and all of the changes that I've made are still there, but the only thing that happens is they update. So they will update to reflect the current changes. You do not have to delete the drawing, you don't have to recreate the drawing, you don't have to redimension the drawing. All that rework is just a huge time drain on your project, and you can eliminate a lot of that just by switching to Tekla Structures. Do the same thing on my handrail drawing. So if I go ahead and jump over to that, I'll give it a second here to update. And again, you can see how the dimensions have modified to now match the new geometry of that rail. So a huge, huge help for handling things like changes, dealing with changes from the field measurements, anything like that that you might have to modify your model for, updated designs could be. All right, so now that we've taken a look at your drawings, let's take a look at CNC files before I move on. Your CNC functionality is built into Tekla. So if I come under my file menu, I choose export, I create NC files. What I'll do is make one of just a stringer for simplicity and for time. So I'll highlight the stringer. I'm going to say, yep, give me what we call DSTV for profiles. So that's a common language for most machines out there. I'm also going to enable contour marking. So contour marking is could also be called scribing, and that's where it's going to sketch out like the outline of welded objects. It can even put on piece marks if you want it to. So I'm going to turn this on, and we'll run a quick numbering to make sure that nothing changed, because that can actually change a piece mark of a stringer if one has scribing and one doesn't. But then we'll create the NC files, and you can see NC files have been written for profiles. So let me open up that CNC file here. I happen to have a free viewer from HGG so that we can review this. Let me drag it over from my second screen. So there's my channel with my copes and my cuts. Here's also a front, top, and bottom view of the piece, and if I spin this around in the viewer, you can see there are the pans scribed onto the channel. So again, this type of functionality is built into Tekla. Really is going to change the game when it comes to fabricating your parts, especially if you have a machine that can do this type of scribing work. Okay, so now that we've talked about more of the traditional bread and butter type stuff, let's take a little bit of a look at more complex framing, complex tools for more interesting steel shapes. I do want to give you kind of an intro to some of this stuff. So we're going to start with plate work. This is going to be a very generic example, very simple example, but hopefully it kind of gets the juices flowing for the type of thing that you can do with Tekla. So if I pick a couple corners and create a simple plate, I'm also going to come off to the side and create some tabs. Like picture I'm creating a box or something like that that's going to be unfolded, or at least be have the ability to be unfolded. So all I'm doing is creating the different sides of my box here, and then we can use a tool called Create Bend Plate Using Parts. And when I activate that, all I have to do is pick two parts, and it will create the bends between them. So you can see it's created the bend between those pieces. There are some options if I enable direct modification. Maybe I don't want it to flare like that. Maybe I want it to keep the skinny side plate, or maybe I want it to keep the fat side of the plate. So you can adjust that stuff along with the radius. We can also go ahead and use direct modify to reshape some of these plates if you want to push and pull the adjustments of them a little bit. Okay, so that basic functionality, which is really cool and allows you to create some really neat stuff, can also be used for a lot more interesting profiles or interesting shapes. So if I come in here and create a small tab, let's say it's a little 1 foot by 2 foot tab of material. If I copy this to a different elevation and I rotate it away, so I'll just go 4 feet away in the Z at a 90-degree rotation, we can use that same functionality to join two plates together that aren't even facing one another. So that creates a curved web vertical plate that it would be perfect for something like a stair stringer. So that type of functionality is that easy to use. Create a little starting point, little ending point, tell them to connect together. Now, if you're doing something with a extruded shape, like a channel or a tube or something like that, we have a spiral beam command. A spiral beam works by picking 2 points, basically setting my radius, and then finally I middle mouse click and it will create, in this case, a spiral channel. Again, maintaining web vertical throughout. If I click on it, I get a properties window where I can adjust the total rise. Maybe I want that to go up to 8 feet. Maybe I want that to rotate 180 degrees. And as you make those adjustments, you can see it's maintaining web vertical and it's making that sweep. So really, really powerful tools for making things like spiral stairs. Now, while we have those tools available, there's always a better way in Tekla. There's always going to be some kind of tool that utilizes that information or utilizes that functionality and makes it a little bit more user-friendly. So let's take a look at that. What I'm going to do is focus in on this next area of the building. So I'm going to pick 2 points here to fit my work area down. And what I'm again doing is I'm working off a set of designs. So this is from the same building as my first stair. It's just another part of the design drawings, another part of the architecturals that locates the beginning of this this swept stair, gives me a radius. So this is where I'm getting my numbers, and I've already built the structure that this is connecting up to. What I'll do is I'll go to my component catalog and I'll do a search for the spiral staircase. So if I search for spiral, you can see there's my spiral staircase tool. I'm also going to set my work plane to that starting point. And again, I only know that because it's given on the architectural drawing, so that's what I'm following. When I go to create the spiral staircase, it's asking me to pick the center and then the direction, like where is the bottom of that stair going to start. Now the default settings you can see are not quite what I want, but it does create that full stair. So then I can just adjust it as needed. If I double click on it, it's going to open up the dialog box. This same tool can create a dual stringer stair like we see here. It can create a single stringer with a central column. We can adjust all kinds of stuff about this. So let's go ahead and start making some changes. Again, I have those values written down here based off of those designs. So from floor to floor, 10 foot 11 3/8. My radius is going to be 24.0 and my width is going to be 4 foot 10. So we'll modify that. We start getting it into the proper position. I'm dealing with an 11-inch minimum nose to nose, so I'm going to enter that value. And you can see that little by little, the changes that I make are adjusting this stair, just like we do for our regular components. We can switch this out if we want. Right now it's putting in spiral beam channels, but if I want to use a bent plate instead, again, it's just kind of wrapping up those tools I showed you, but inside of this nice interface. I'm going to go with a spiral beam. Based on the designs, we're going to go with a HSS, make sure my caps are on, HSS 12 by 3 by quarter. I could also pick this from our catalog. Sometimes it's easier just to type. So I'll modify, and then we'll make some adjustments to our step. So our step, again, minimum width is 11 inches. I'm going to change the shape of it, modify it again. And I think the last thing I want to do is extend the top out. I'm going to give me a little extra meat at the top in case I want to, connect that to something up there. So now that I've got this in, you can see how quickly I was able to make this stair using this tool. And all it is all the stuff that I've already showed you just kind of bundled together in a nice clean interface, a nice clean dialog box. Now this stair is creating a simple plate step, but we can also create custom steps for this. So let's take a look at what that process is going to look like. The designs call for a concrete filled pan with a perforated metal riser on there. So first off, I tried to find a perforated riser from a manufacturer, but what I ended up doing was just creating it in Tekla. Let me close this dialog box out of the way here for a second. So you can see it's just a plate with a bunch of cuts in it. I made it the width that I needed it to be, again, only because I couldn't find one online. We can import a lot of stuff, step files, SketchUp files. So if you can find something from an external source, great. If not, just go ahead and build it like I did. So I'm going to set my work plane. I'm going to save this object away. I don't feel like recreating it with multiple cuts. So we can create what we call in Tekla an item. An item is going to be a saved away custom shape. In this case, a perforated riser. But this could also be something like a handrail bracket. This could be a hinge. This could be a clevis. It could be a lot of different things. But I'm going to highlight this object and say create. And now that's been saved away. So an item is created with a different tool. There's actually an item button on my steel toolbar. What we can do is choose that from my shape catalog, and to recreate one, all I would do is pick 2 points. So now I have that permanently saved away, and I can reuse it obviously very, very quickly. So let me just set up a couple more properties here. I'm going to call this guy riser. We're going to make it aluminum. And I'm going to want to turn this upright. So we'll set it up with those settings to begin with. So I'll come over here and we're going to start building an actual step with this riser, okay? So what I'll do first, I'll use the tool, the actual stair tool, to make a thinner pan. So rather than, or a thinner plate to begin my pan. So instead of having a 13/16, we'll make this 1/16. So I will modify. And then we're going to move, and I'm just going to reuse this because I like reusing work if I can. Let me clear up my screen a little bit here. Let me hide these stringers temporarily, kind of make my life a little bit easier. All right, so we will move this guy down, creating a 2-inch deep pan for concrete. I'm going to reuse the properties of that step to draw in the rest of my plate. Now, I cheated a little bit. I have some work points in here to help me out. Again, this is just for time's sake. Obviously, it would not be difficult for me to just do some offsets and create those again. But I have those edges of my pan created. I'm going to recreate that riser, and since it's kind of moving, I'm curving upwards, I'm going to come back a 1/2 inch on one side. So let's go a 1/2 inch over, just track till we get to a 1/2. On the other side, we pan over a little bit, we'll come back a 1/4. And I would probably take a little bit more time to measure this out, as you can understand. But I've created now a custom step of sorts. Let me use that bent plate tool to join the bottom and sides together. So we'll go to the create bent plate using parts. We'll pick those 2 pieces, and then we'll pick those 2 pieces. Okay, so now that we have that put together, they are still separate pieces. So if I want to reuse them, I'm going to have to copy, 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 copy. And I'd rather not. I'm all in favor of making my life easier. So here's what we'll do. We'll turn this into a custom component. So a custom component is like a custom tool or a custom block. So I'm going to define this custom component. I'm going to call this custom step. And we'll say next. Pick the objects that are going to be created by my custom step, and then I'm going to pick the 2 parts of my nosing line. That's really the critical point for locating this thing. Okay, so finally I'll finish, and now I have that saved as a custom step. So if I want to use that, I can actually go back into the stair tool now. If I just reload the default settings, it's just going to go ahead and put a plate back in for me. Let me make this rendered solid so we can see that a little clearer. So it just recreates the step. But if I go to the Parts tab, I can choose step properties to be a custom component. If I go under Custom Component, there's an option for Custom Step. That's the one that I just saved. So I'll modify this. And you can see how it uses my custom step now all the way up to the top based on the, all the dimensions that I've entered so far, the 11-inch minimum, all that good stuff. Now, unfortunately, the spiral material, the spiral stringer, because of the complex geometry, our default tools to cut and shape that will not work with that. But that just means it gives me another opportunity to switch to a manual mode. So I'll go ahead and I'll cut myself a temporary view at that location. And then I'll go ahead and just cut this stringer. So I'm going to make things a little bit transparent so I can see this better. Go to my Edit tab, and here I have all of my cutting tools. So at this point, I'm just manually cutting this thing apart. I'm going to come over an inch. I'm going to come down and clip off the end of that stringer. And then I'm going to do the same thing for the bottom. Let's account for like a 1/4 inch plate. and then I'm going to cut off the bottom of that. So that quickly I've been able to create the cuts to really, shape the bottom of that stringer the way I want. And then we can use the plate tool and just draw in, our closure plates. So I'm going to make this a 1/4 inch thick. We will just pick, connect the dots coming around that cut end of the HSS. And then I'll do the same thing for the very end of it. Okay. Last thing you want to do when you're manually modeling like this is make sure that everything is welded together. Again, you want to mimic what you're doing in the shop, and I could do this for the other side in the top, but you get the general idea of how you can create these ends. And the last thing I really want to show you is another tool that's available on the warehouse. This one creates my curved posts for me. So again, because of the complex geometry, the regular straight stanchion tool won't apply to that, but we do have a custom extension that's available in the warehouse called curved stanchions. All you have to do with this guy is pick on that curved member and it will create equally spaced posts along it. Now it does match the original length, so you have to account for the things that you cut off, the material that you cut off, but that's not a big deal. I'll just go ahead and adjust that dimension. It will respace those for me along that stringer. For the actual railing, this is where I might use the polybeam tool again. At this point, again, you're kind of switching to a manual modeling mode, but a lot of this stuff is being automated, and we're working on new tools all the time to make this even faster. So even if you do have to do a little bit of manual work, like tying this together, again, you're getting all the benefits of a 3D model from this. Center of gravity, BOMs, all that good stuff. So I just put in a constant polybeam pipe across the top of that, and then I'll just grab all those handles and tell them to be a nice curved chamfer. Okay. So I think we're going to wrap it up there. We're getting close to the hour mark. I do want to have some time for a little bit of Q&A. Again, a lot of these tools are on the warehouse. I definitely recommend checking those out. Again, the YouTube page is a great place to go get some information about a lot of these tools that I've showed, that Lee Snyder has showed. So thank you for joining us today. And at this time, let's go back and start looking at some of the questions that have come in.